Hello, welcome to another video on vectors. Today we're doing question 7 of June 2012. Where is it? There it is. Yeah, I'm going to go straight into it. I think you probably know the routine by now since this is the third video I've done. I'm going to go straight into it. So you've got line 1, that has that line equation vector. We also have, we've got an unknown in there. We've got line 2, which is this line equation vector. It hasn't got an unknown. And they both intersect at point P. First question is, show that Q is equal to 4, hence, so find coordinates of P. So this would just be a simultaneous equation. So essentially we've got this equal to this. So all the x components will equal each other, all the y components will equal each other, and all the z components will equal each other. Because it says it intersects, I don't think we actually have to prove that it is intersecting. So we can just make that assumption that it is intersecting. So the first one would be 0 plus 2y, not 2i, 2 lambda. That's equal to 8 plus 2 mu. So that's one equation. Other equation is just minus 2 is equal to 3 plus 5 lambda. Oh, not mu. Can't talk today, or can't read today. And then we've got that unknown, which is q minus lambda is equal to 5 plus 4 mu. It's at this point, I'm just going to plug these two into the equation solver on the graphical calculator. So let's see. So the only problem with your graphical calculators is that they have the format of, I'll bring over ax plus by equal to c. You can just say that's maybe mu and that's lambda. It doesn't really matter as long as you get the constants correct and a constant on the other side. So I'm just going to rearrange these. So I'm going to call my lambda x, in fact. So let's just delete that. So that's x is x, lambda is x, and then mu is y. So yeah, I've got 2x minus 2y is equal to 8, and on this one I have 0x, let's say plus 5 mu is equal to minus 5. In fact, we've already got an answer, so I'll just plug it into the graphical calculator anyway, just to make sure it is good. I'm pretty dumb like that. 0, 5, minus 5. So when we solve it, we have x or lambda as 3 and mu as, well, it says there minus 1, and we got minus 1. So I'm sure mu and lambda are 3 and minus 1. I said it the wrong way around, but yeah. So now we've got this equation here, so we need to find q. So q minus that 3 is equal to 5 minus 4. So if we bring the minus 3 over, I'm going to plus 3. And that would just be minus 1, so q is equal to 4. So on the point P then, it's just, if I just use this one here, lambda is 3, so it's going to be 6, or 0 plus 6, and then minus 2 plus nothing will be minus 2. Now we've got 4 minus 3, so 4 minus 3 will be 1. So there are my points for P. And so at this point, I'm not entirely confident with my answer, because it's like first thing in the morning. So I will check it, because I think it becomes really important. So if I screw it up at the start, then I've screwed it up all the way. It's really annoying. There we are, 6 minus 2, 1, yay! And smile, yay. So now we go to the next question. Show that L1 and L2 are perpendicular. So they've just told us it intersects. Now they're saying show that it intersects with a right angle. So what I'm going to do is just dot product. And I don't really care about these position vectors at all. It's because in your line equation it's these three vectors that give its direction. So we're just going to dot 2, 0, minus 1, and 2, 5, 4 together. So 2 times 2 is 4. That times that is 0. And then that times that is plus minus 4. So that does equal 0. So equals 0, therefore per. Alright, now it's saying that the point A lies on the line when lambda is equal to 1. Find the distance AP squared. So we want, which equation is it? Line 1. So we want this one. We just want to put lambda as 1 in there. So it'll be 0 plus 2. So 2. And then it will be minus 2 plus 0. So that will be 0. I mean minus 2. And then what's Q? Q is 4. So 4 minus 1. So 4 minus 1 is 3. So our point A is right there. It wants us to find AP and square that though. So what I'm going to do is I'm going to use my coordinates for P right here. So what was that? 6 minus 2 and 1. And I'm going to minus away my coordinate A. So 2 minus 2, 3. So what I will end up with is the vector AP. So AP is equal to 4, 0, and then minus 2. I think that's it. Let's just double check it. 4 minus 2 is, sorry, 6 minus 2 is 4. Minus 2 plus 2 is definitely 0. Yeah, that should be right. But then we want to find AP squared, or the magnitude of AP. So we're just going to do 4 squared and 2 squared, or minus 2 squared. Already done it. 16. So that should be equal to, we want to add them up, so 16 plus 4, technically there's a 0 squared there, but we want to add 0. So that should be equal to 20. Let me check the answer. Yeah, there you are, 20. So we got 20 right here. Next question is, the point B lies on line 2, such that the right angled triangle APB, there's a right angle, is an isosceles triangle. Find the coordinates of the two possible positions of B. Alright, it's a 6 marker, so it is pretty complicated. I've drawn one possible setup, so B can be here. The other setup, using that exact same diagram, so A to P, B can also be over here. So there's two possibilities for B. If you've done your A to P as a vertical straight line, it can either be to the right or to the left. Because going to the right or going to the left does give you a right angle at APB. So we want to find that coordinate and this coordinate, or on this one diagram, these two coordinates here. Let's have a look. It's isosceles, so we're going to use that fact. So isosceles means that's the same, that's the same, that's the same, that's the same. And also, if I dot this in, this angle, I'm going to just call x, the same as that angle x. Likewise, dot this in, that's x, and that's x. It doesn't entirely make sense to find an angle x, just because we haven't been working with any angles throughout this entire question at all. Whereas we did just find the magnitude of AP. And now the magnitude of AP is this distance right here. So we've just found that distance. And if you remember right, for isosceles, whoa, Jesus! Sorry, I was almost knocked my ukulele off. Um, oh, that was a heart attack. If you arrive at isosceles triangle, they've got two equal lengths here. If the right angle is here, then it's got to be these two angles, or sorry, lengths that has to be the same. So PB must be the same length as AP. So we're going to use our previous answer to help us find a couple of things. So what I want to find is P to B, and the magnitude of P to B, or its squared, is going to be equal to 20. In fact, no, I've been using the wrong terminology. This thing right here, AP squared, that's not the magnitude. I have to square root it to make it into magnitude. So I'm talking nonsense actually. But essentially it's the magnitude squared. So yeah, we'll find the magnitude squared. So P to B must be equal to, or P to B squared must be equal to 20. All we need to do is just find out what B is. B is on the line L2, so if we go back to this equation here, in fact, I am just gonna, I can't steal it. I'm gonna steal it now, so let me just copy and paste that. So if we copy and paste that somewhere, there it is. What I'm going to do to find B is I'm just going to squish it together. So coordinates for B is just 8 plus 2 mu, 3 plus 5 mu, and 5 plus 4 mu. So that's my coordinates for B. What I also know is coordinates for P. Where's that? Is that it? I should really label my answers. So 6 minus 2, 1. I think that's it. 6 minus 2, 1. And again, to find the vector P to B, I need to do B minus P. So I've got B here. If I minus P now, that will find me, technically I should use lowercase. So P, and that's B. So from P to P, P to B, I'm going to do position vector for B minus position vector for P. So at the end of the day, it's going to be that minus that. So PB is going to be equal to 2 plus 2 mu plus 2, so 5 plus 5 mu, and minus 1, so that's going to be 4 plus 4 mu. So that is it there. So now I have PB. Now we can use the fact that when we found AP squared equal to 20, if AP and PB are the same, so we can use this fact here. So PB squared has to also be equal to 20. So if I squared this, that has to be equal to 20. So let's just try to square it now. So 2 plus that squared, and now I've got 5 plus this. I also want to square that, and 4 plus this. I also want to square that, and I want to add them all together. Wow, this is long and tricky. So square the first, double the product, and square the last. Again, square the first, double the product. What's the product? It's 25, and square the last. Square the first, double the product. Oh no, I'm done. It'll be 16, so 32, and square the last. Wow, we've got loads of stuff to do. Alright, I'm going to do all the constants first. So 4 plus 16 gives me 20. So 20 plus 25 equals 45. We'll do all the mu's then. So I've got 8 plus 32, that gives me 40. So I've got 90 mu there when I do 40 plus 50. Likewise, I'll do this again. It's going to be symmetrical because I've got 4, 25, 16, 4, 25, 16. That should be 45 mu. And that is equal to 20. Let me just double check my maths. So they're all going to be positives, so I've got positive answers here. I'm pretty sure that was P. Yeah, I think I'm happy with that. So all I'm going to do is make this equal to 0, so that's a squared. So all I'm going to do is make this equal to 0 by bringing the 20 over. So if I minus 20, it will be 25. And I'm just going to punch that into my equation solver. So what polynomial degree 2, my A is 45, my B is 90, and my constant is 25. If I solve that, I've got pretty horrendous numbers. So I've got mu is equal to minus 0.333 recurring, so let's just call it minus a third. And we've also got this one here, mu is equal to 1 or minus 1.6 recurring as well. Yeah. So what's that? Minus 5 over 3? You check. They won't let me check. Damn you, graphical calculator. Yeah, 5 over 3, yeah. Yay. Wonders of technology. And the stupid man behind it. So I'm gonna go with that. I am a bit worried about my answers because they look weird, but I'm just gonna go with it. So it's saying that mu can be this value or mu can be this value. What is that actually telling us though? We've got two solutions, which again is a bit weird. What that is actually telling us is we didn't actually specify whether B was on the left or the right. We just put an equation for the coordinates B. Now, when we solved that equation for B, we had two solutions, and those two solutions represent one on the left and one on the right. So these two mu values tell us our two B values, or two B coordinates, and that will tell us, hence the final question, find two possible values for B. I'm just going to substitute my mu into that equation right there. So our first one is, let's go with the minus third. So again, I'm going to use my calculators because I'm dumb. So I'm going to do 8, and it's minus 2/3. So that gives me 7.3 recurring for one coordinate, for my x coordinate, sorry. I'm going to do 3 plus 5/3, and again that gives me 4 and 6 recurring basically, or 2/3. And now I'm going to do 5 plus 4/3, and that gives me 6 and 3 recurring. So I'm going to call that one coordinate for B. So let's just call that B1, for the position vector B1. If I want to write it as coordinates, I'll just do 7.3, 4.6, blah 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 blah. They probably do want you to write in coordinates, so I might lose a mark if these two numbers are correct. Next we're going to do 5 over 3, or minus 5 over 3 now. So let's just say B2 is equal to, so it's 8 minus 10 over 3. So that's 4.6 recurring. Next one is 3. Was it 5 over 3? Yeah, it's 5 over 3, so it's 25 over 3 now. So minus 25 over 3. That gives us 5 and a third. Ooh. I've got these two numbers wrong. I know why, because I've been plussing them. which isn't wrong. You do plus 5 mu, but mu is a negative. So yeah, these two are wrong. So I'll come back and correct those in a minute. 4 times, so sorry, 5 minus 20 over 3 then, for the last coordinate of our second coordinate. So that will be minus 1.6 recurring. So I'm pretty sure those are correct because I've been minusing them. But these two are definitely incorrect. So let's just go back to the drawing board. So it will be 3, what was our mu again? Mu is minus a third. So it will be minus 5/3. And that gives us 1.3 recurring this time. So 7.3 recurring, that should be correct. And now it's 5 minus 4/3, and that's 3 and 6 recurring. Let me write that out again because it looks kind of messy. So my possible value for B or B1 is going to be coordinates 7 and 3 recurring. I'm going to call it 7 1/3 and 1 1/3 and 3 2/3. Likewise, my other coordinate for B is 4 2/3, 5 1/3, and minus 1 2/3. So again, I wasn't entirely confident with my mu values, so I do want to check them. So let's have a look. I can't get to. There we are. So where we are. So where's the mu? Minus a third and minus 5/3. So yeah, they were good. So that's good, and that's good. So my answers should have been good, assuming I actually did the maths correctly. So we've got 22/3. I have no idea what 22/3 is. 22/3. No, that's 22/11. 22 divided by 3. So it's this one. So 22/11. 22/3. Why do I keep saying 11? It's because it's 22. 22 is a multiple of 11. That does equal 7 and 3 recurring. So it's this one here. So that's good. Then we have 4/3. 4/3 is 1 1/3. And we've got 11/3. And 11/3, let me double check, does give us 3.6 recurring. So that one's correct. Let's check this one. 14/3. Can't do that in my head again. 14 divided by 3. Does give us 4.6 recurring. So that one's good. Next one is 16/3, which does give us 5 and 3 recurring. This next one, I'm just going to check the sign. So it's minus 5/3. And here we have minus 1 2/3. So that's good as well. So that was it. The difficulty was just setting up this diagram here and knowing you've got 1B here and 1B here, 1 coordinate here and 1 coordinate here. And also the fact that you had to use the fact that it was isosceles to use your answer in C part I. So C part I, you found one length of the isosceles triangle, and then you used that length again to find out find where the B coordinate was. So you could have gone to the left with that 20, or to the right with that 20. In fact, I went the wrong way around. To the left 20, or to the right 20. And that 20 isn't the distance. I thought we were finding a magnitude. It is probably the magnitude squared. But that is it. I hope you found that useful. Stop. Where the hell did you stop? Where's the mouse? There's the mouse.